Welcome to Distributed Systems Interview Crashcasts, a podcast designed to help you ace your next back-end engineering interview. I'm your host, Sheila, and today we're joined by Victor, a seasoned distributed systems engineer. Victor, thanks for being here.
Thanks for having me, Sheila. I'm excited to dive into this topic.
Great. Let's start with a common interview question. What is a distributed system, and what are its key characteristics?
Excellent question, Sheila. At its core, a distributed system is a collection of independent computers that appear to users as a single coherent system. These computers, often called nodes, work together to achieve a common goal.
That's a good starting point, Victor. Can you elaborate on some key characteristics that define distributed systems?
Certainly. 3 primary characteristics come to mind: scalability, fault tolerance, and consistency. Scalability allows the system to handle increased load by adding more resources. Fault tolerance ensures the system continues to function when components fail. Consistency deals with ensuring all nodes have a coherent view of the system's data.
Those are important points. Let's dive deeper into scalability. How do distributed systems achieve this?
Scalability in distributed systems is achieved through horizontal scaling, also known as scaling out. Instead of upgrading a single machine, which we call vertical scaling, we add more machines to the system. This allows for better load distribution and increased capacity. Technologies like load balancers help distribute incoming requests across multiple nodes.
Interesting. What about fault tolerance? How do distributed systems handle failures?
Fault tolerance is crucial in distributed systems. It's implemented through redundancy and replication. Data and services are copied across multiple nodes, so if one fails, others can take over. We also use techniques like sharding to spread data across nodes, reducing the impact of a single node failure.
You mentioned consistency earlier. Can you explain the challenges around maintaining consistency in a distributed system?
Consistency is one of the most challenging aspects of distributed systems. Ideally, all nodes would have the same view of data at all times. However, due to network delays and potential failures, this isn't always possible. We often have to make trade-offs between consistency, availability, and partition tolerance, as described by the CAP theorem.
That's a great point about trade-offs. For our listeners who might not be familiar, can you briefly explain what the CAP theorem is?
Of course. The KP theorem, proposed by computer scientist Eric Brewer, states that in a distributed system, you can only guarantee 2 out of 3 properties: consistency, availability, and partition tolerance. It's a fundamental concept that helps us understand the limitations and necessary trade-offs in distributed systems design.
Thank you for that explanation. Can you give an example of how these trade-offs might play out in a real-world scenario?
Sure. Consider a global social media platform. They might choose to prioritize availability and partition tolerance over strong consistency. This means that when you post an update, it might not immediately be visible to all of your friends around the world. The system accepts this temporary inconsistency to ensure the platform remains available and responsive, even if some parts of the network are disconnected.
Excellent example. Now let's consider an edge case. How would a distributed system handle a network partition where half of the nodes can't communicate with the other half?
That's a challenging scenario known as a split-brain situation. The system needs to have predefined protocols to handle this. One approach is to use a quorum-based system, where operations are only allowed if a majority of nodes agree. This prevents both halves from making conflicting changes. Another strategy is to designate a minority side that goes into read-only mode until the partition is resolved.
Thank you, Victor. That's a comprehensive overview of distributed systems. To wrap up, could you share some tips for engineers preparing for interviews on this topic?
Certainly. First, understand the fundamental principles we discussed: scalability, fault tolerance, and consistency. Be prepared to discuss trade-offs, as they're central to distributed systems design. Also, familiarize yourself with real-world distributed systems like Google's Spanner or Amazon's Dynamo. Lastly, be ready to think through scenarios and edge cases as we did with the network partition example.
Excellent advice, Victor. Listeners, remember that interviewers are often more interested in your problem-solving approach than perfect answers. Don't be afraid to think out loud and discuss trade-offs. That brings us to the end of today's episode. Thanks to Victor for sharing his expertise, and thank you for listening to Distributed Systems Interview Crashcasts. Until next time, keep learning and stay distributed.